Welcome to another in the series of astronomy basics videos from Space Oddities. In this video we'll be asking the question, what is a galaxy? Just as the Earth's population is clustered into cities, so stars cluster in galaxies. They are the cities of the universe. A galaxy is an immense metropolis of stars numbering millions or billions. There are an estimated 2 trillion galaxies in the universe. Between the galaxies there is just cold, dark, empty space, devoid of stars, stretching for perhaps millions of light years in every direction. Stars in a galaxy, like the one shown here, orbit its centre, held in the eternal grip of gravity. Galaxies themselves may also cluster, as shown here in this NASA image of Stephan's quintet, a galaxy cluster imaged at infrared wavelengths by the James Webb Space Telescope. Gravity draws the galaxies together into complicated dances. As with skaters on a packed ice rink, collisions are inevitable. However, the encounter takes place over millions of years, during which time the galaxies slowly merge to form one single giant galaxy in a series of elegant dances, choreographed by gravity. All these images show galaxies at various stages of merging, pulled into twisted, distorted shapes by their mutual gravity. While these might seem like giant cosmic catastrophes, in reality space is so vast and the distances between stars so enormous that collisions between individual stars are extremely rare. Galaxies are so tenuous that galaxy mergers are like clouds passing through one another. It was the great American astronomer Edwin Hubble who, in the 1930s, was the first to attempt a systematic classification of galaxies based on what he observed. His resulting diagram, shown here, is sometimes referred to as the tuning fork. Hubble classified galaxies into 3 main groups: ellipticals, spirals, and barred spirals. We now know that there are other types of galaxy, but the vast majority of galaxies in the universe fall into one of these 3 categories. Today, Hubble's tuning fork diagram still serves us well as a basic categorization of galaxies. So let's talk about one of Hubble's main classification of galaxies, the spiral galaxies. This archetypal classification of galaxy consists of one or more spiral arms of stars sweeping out from the centre like the arms of a Catherine wheel. At the centre of the galaxy is a bright core of stars separated from each other by astronomically small distances, perhaps 10 million stars per cubic parsec, 1 parsec being 3.23 light years. This core of stars forms a sphere-like structure at the centre of the galaxy called the galactic bulge. This means that the galaxy in profile resembles 2 fried eggs stuck back to back. Right at the very centre of most galaxies is a supermassive black hole, which may possess millions or even billions of times the mass of our Sun. There is a direct linear relationship between the mass of the galactic bulge and the mass of the supermassive black hole, but what this relationship signifies is as yet unclear. Most star formation in galaxies occurs in the dusty spiral arms. When we look up into the night sky from a dark location free from light pollution, we see one of those spiral arms of our galaxy arcing overhead as a ghostly cloud, a river of light made up of countless stars. This we call the Milky Way. Now this can be confusing, as our entire galaxy is also called the Milky Way. When we see the Milky Way in the sky, we are looking inwards towards the middle of the galaxy. The actual centre of our galaxy lies in the constellation of Sagittarius. Another of Hubble's classifications is barred spiral galaxies. Barred spirals, as their name suggests, are a type of spiral galaxy where a bar of stars extends either side of the galactic core. The spiral arms emanate from each end of the bar, as you can see in this illustration. 2/3 of all spiral galaxies are barred spirals. Surprisingly, our own Milky Way galaxy is a barred spiral, although this was not discovered until 2005 from observations made with the Spitzer Space Telescope. The bars in barred spiral galaxies form when the orbits of stars in the galaxy's inner disk become unstable and deviate from a circular path. This can happen for a number of reasons, including interactions with other galaxies. When two galaxies merge or even just pass close to each other, the gravitational forces can disrupt the orbits of stars in both galaxies. This can lead to the formation of a bar in one or both galaxies. Disk instability. The disk of a spiral galaxy is constantly rotating. This rotation creates a centrifugal force that pushes stars outward. However, the gravity of the galaxy's central bulge pulls stars inward. If the centrifugal force is not strong enough to balance the gravitational pull, the disk can become unstable and form a bar. Gas accretion. Spiral galaxies are constantly accreting gas from their surroundings. This gas can fall into the galaxy's disk and spiral inward towards the center. As the gas falls in, it can lose energy and cause the stars in the disk to slow down, and this can lead to the formation of a bar. Once a bar forms in a spiral galaxy, it can grow over time by attracting more and more stars into its orbit. The bar can also drive the formation of new stars in the galaxy's center. This is because the bar can channel gas and dust towards the center, where it can collapse and form new stars. Bars play an important role in the evolution of spiral galaxies. They can help to distribute gas and dust throughout the galaxy, and they can also drive the formation of new stars. Bars may also be responsible for the formation of active galactic nuclei, or AGNs, which are regions of intense star formation and black hole activity at the centers of some galaxies. The main features of an elliptical galaxy are an elliptical shape. Elliptical galaxies have a smooth ellipsoidal shape. They can range from being almost perfectly spherical to elongated ovals. Little gas and dust. Elliptical galaxies contain very little gas and dust. This is because most of the gas and dust in these galaxies has already been consumed to form stars. Old stars. Elliptical galaxies are primarily populated by old stars. These stars are typically red and low mass. Random orbits. The stars in elliptical galaxies have random orbits. This means that they do not move in a disk or spiral pattern, as is the case in spiral galaxies. Large size. Elliptical galaxies are typically very large galaxies. Some of the largest galaxies in the universe are elliptical galaxies. Preferential location in galaxy clusters. Elliptical galaxies are more likely to be found in galaxy clusters than in the field. High luminosity. Elliptical galaxies are also typically very luminous galaxies. This means that they emit a lot of light. Central supermassive black holes. Elliptical galaxies are thought to contain a supermassive black hole at their centers. The mass of the black hole is correlated with the mass of the galaxy. It is believed that elliptical galaxies form as the result of collisions between two or more galaxies. In the distant future, perhaps in about 4 billion years, our own galaxy and the Andromeda galaxy will collide, merge and form an elliptical galaxy, their graceful spiral forms completely disappearing over millions of years, consumed and torn apart by gravity's relentless maw. This is why elliptical galaxies contain very old stars. They are remnants from the galaxies which collided. Elliptical galaxies, with their paucity of gas, are incapable of giving birth to new stars. This is elliptical galaxy M87 in the constellation of Virgo, some 53 million light-years away. Emanating from its centre is a jet of plasma, extending for 5,000 light-years. This jet originates from a supermassive black hole at the centre of the galaxy. In 2017, the Event Horizon Telescope managed to image the black hole in an incredible feat of technology and ingenuity. The radio image of the M87 black hole was on front pages around the world and has since become iconic and will no doubt be written into the history books as our first definitive proof that black holes exist, all evidence of such having hitherto been circumstantial. Well, apart from the main Hubble classifications of galaxies, there are other types. Dwarf galaxies usually comprise just a few million stars and are tiny in comparison to other types, hence their name. They are often found orbiting spiral galaxies, such as the 50 or so found around the Milky Way. Ring galaxies are very rare and comprise a ring of stars surrounding a bright central core. It's not known at present how they form. Irregular galaxies are amorphous galaxies having little or no structure. It's possible they may be the results of galactic collisions. Lenticular galaxies are lens-shaped, hence their name. They are midway between a spiral and an elliptical galaxy. There is much we do not know about how galaxies form and evolve. It is one of the most intense areas of astronomical study. The James Webb Space Telescope, looking back to the dawn of the universe, has shown us early galaxies just a few 100 million years after the Big Bang. How galaxies evolve so quickly in such an astronomically short period of time is not well understood, but it is to be hoped that further JWST observations will shed some light on the conundrum. This image shows some of the very early galaxies imaged by the JWST. It is incredible that we are able to look back in time to the infant universe before the formation of the majestic spiral galaxies. Well, we hope you've enjoyed this introduction to galaxies. Just to summarise, galaxies are vast cities of stars. They're categorised using a system developed by Edwin Hubble. They fall into three main categories: spirals, barred spirals and ellipticals. Galaxies can form clusters comprising up to hundreds of galaxies, and all but a few galaxies have supermassive black holes at their centres. Don't forget to check out our other Astronomy Basics videos in the playlist of the same name on the Space Oddities YouTube channel. Until next time, goodbye.